designed this unit using the ADDIE model. The learning goals incorporate the processes for rock and fossil formation. I teach 8th grade integrated science. My class consists of 22 boys and 17 girls. One student is receiving services for speech and language. 2 students have been diagnosed with ADHD. Lucky for me, when surveyed, most of my students report liking school. Most prefer a mix of learning strategies and also a mix of quiet versus active learning environment. They overwhelmingly agreed that participating in class discussions helps them learn. All but one of my students report having access to a computer with internet at home. The one student without access reported having access at the library and at his grandmother's house. 90% of the students surveyed personally own a device that has internet capabilities. Fortunately, 100% of my students read at an 8th grade level or above, and 90% of them complete work on time. When surveyed, some of my students had a poor attitude about science, so I've worked hard to make my hooks more enticing and to add more labs and learning games. Let me tell you about my unit design. The goal of this unit is to integrate science, English language arts, history, and math into understanding the processes of rock and fossil formation. Prior to beginning this unit, the students should already know the 6 main energy types, have basic knowledge of chemical and physical properties, be able to read and write at an 8th grade level, have basic lab and lab safety skills, and have a working knowledge of taking Cornell notes. In this unit, there are 5 learning objectives. First, describe how energy from the Earth's interior causes changes to Earth's surface. Second, describe how earthquakes and volcanoes transfer energy from Earth's interior to the surface. Third, model the process of energy buildup and release in earthquakes. Fourth, investigate and report possible reasons why the best engineering or ecological practices are not always followed in making decisions about building roads, dams, and other structures. And last, model how small changes over time add up to major changes to Earth's surface. The instructor should understand that Earth is a dynamic planet. Processes that change Earth's surface operated in the past much as they do today. Evidence of past surface and climatic changes are indicated in the rock and fossil records. And that rocks are composed of minerals, and rocks and minerals cycle through processes that change their form. Now let's talk about development. We started out learning about continental drift and did a Pangea puzzle. Then we learned about plate tectonics through a presentation and took some Cornell notes. To reinforce plate tectonics and other crustal movements, we did a lab called Candy Quakes. The Ring of Fire activity was next. We plotted earthquakes and volcanoes and checked to see where most of them occur. We then made posters about energy in earthquakes and volcanoes using comic life. Lastly, we read a news article called In Search of Earthquake-Proof Buildings and used evidence from it to write persuasive essays about whether laws should require more stringent building codes. Implementation went well. The students seemed to enjoy the lessons. However, the Ring of Fire activity took 2 class periods. Plotting all of those earthquakes and volcanoes took longer than I expected. My students scored very well on the post-test. 95% of them scored at an 80% or above. This is a big improvement from the pre-test, where only 19% scored that high. The results of the survey I gave were a little bit surprising. Overall, the students thought most of the lessons were effective. But surprisingly, only about half of them reported that the Candy Quakes lab helped them better understand crustal movement. I was surprised by this. Their reaction to the essay writing assignment was not surprising, however. We've really given them a lot of opportunities to practice persuasive writing lately, and I think they're just tired. The only other real complaint from the students is that my room is too cold, but the new building should fix that next year. Well, I'm exhausted, but I did learn a lot from this process. I have a big zit and probably a few more wrinkles, but this is what I learned. Taking the time to analyze my students really paid off. I had no idea my students had a poor attitude about science. The analysis helped me to solve that problem, and I think we were successful. I was able to improve my hooks and relate the information more to my students' lives. I also integrated some technology and let the kids use the iPads, which is always motivating. The other part I thought was so valuable was the survey at the end. The lab I thought would be the most successful turned out to be the one the students thought was the least effective. This is great information because it allows me to make some necessary changes to improve the lab. Although using the ADDIE model was time-consuming, I'll probably use parts of it again. One thing I'm not in the habit of doing is asking for my students' opinion. But I found this part of the ADDIE model invaluable and will do it again. Getting my students' perspective can really help me to become a better teacher. So that's the end. Thank you for joining me on this journey through the ADDIE model.